Good morning, sirs and ma'am. I'm Lau Wen, and I'll be presenting to you my final year project. So these are the contents of this presentation. So energy demand and crises are happening in this world. So the problem will lead to energy costs are rising and fluctuating, which are harming consumers and companies, changing how they choose their fuel and delay the goals of attaining universal and access to energy. So the solution is thermal energy harvesting to develop systems that will eventually lead to sustaining and boost effectiveness of the system that are not sustainable. So this will utilize the energy expended in the function to continuously power themselves. Hence, my objective of this project is to generate electricity with an array of Stirling engines. So a small history of Stirling engine is that it's invented in 1816 by Robert Stirling. It converts heat energy from an external source to mechanical energy. So firstly, the heat from the outside will increase the temperature of the gas and the pressure in the displacer pistons to move. So as the piston moves, it will push the hot gas into the cooler gas, which is the power piston. So as the gas exchanges, it will push the crankshaft and turn the flywheel. Then the generator will be running, hence creating a workable running electricity. So linking back to my project, thermal energy. So I will talk about the heat source that I've used. So throughout the experiments that I've done, the Stirling engine requires 400 degrees Celsius and above to run. So hence, the suitable heat source that I could find is the heat gun, which has the ability to reach up to 600 degrees Celsius. So next, I will share with you the prototype. So the Stirling engine will be placed at alternate heights, putting in consideration that the airflow will be blocked by the piston in front. So as in putting the Stirling engine in a different height will be a better airflow for each piston. So as the aluminium bar is used to allow heat to flow through the heat, as aluminium is a good conductor of heat and it lowers the risk of combustion. So next, the wooden board base is used to support the engines and prevent the engines from shaking violently. So the heat gun holder, an aluminium bar and additional items is used to secure the heat guns. So this is the schematic diagram that I've created. So the additional circuit is to use to stabilize the output voltage. So each engine has an individual set of circuit that consists of a 1 ohm resistor, 1 ampere diode, and a 470 microfarad capacitor. So a diode is a semiconductor gadget that effectively switches current in one direction while limiting the current flow in the opposite direction. So this will help to protect the generators. So the capacitor stores the charges. Not only that, it removes the noises from the voltage so that I can have a more stable output voltage. So the individual circuit from the engines will be then connected in series to an aluminium source. So this is the circuit connection on the breadboard that is driven by the generators that is connected to the flywheel in the Stirling engine. So the experiment and result of the project. So during the experiment, I used LabVIEW program and National Instrument devices for me to monitor and collect data to perceive and work out the results. So using LabVIEW, I can see that the temperature and voltage when the system is running. So this will assist me in data acquisition. So simultaneously, all the data will be collected into an Excel file. So the figure above here is a front panel of how the LabVIEW look like. So the data collected at a different temperature point. So as you can see, the temperatures are all very high. So from the data collected, I can see that 3 running Stirling engines can produce up to 10 volts. So with the LED is connected, the voltage will be put down a little due to some current that is drawn back from the load. So although the data collected show that the voltage is low, it still show that the light output is being shown significantly. So the power is obtained by multiplying the voltage across the resistor R4 as well as the output voltage from 3 engines. So the power is around 1.5 watts to 2 watts. So with the data, I can collect the efficiency of the system. So the efficiency is calculated by using the formula for the output power of the system across the heat input. The heat input is calculated by finding the mass of the aluminium bar, the specific heat of the aluminium, and the temperature difference. So the power output is calculated by finding the power across 3 engines, multiplying the time taken when the system is running. So with these output values, I'm able to calculate the efficiency. Hence, the efficiency of the system is 23%. Stirling engine have the ability to generate electricity with a proper heat source. In a future application and development, we can use engine energy from the sunlight to concentrate its heat through the parabolic dish into an array of Stirling engine to produce electricity. This will help to save energy costs and be more sustainable. So thank you for your attention. Can I have the judges to move inside the room for a demonstration?